Today's lesson is going to be Properties of Parallel Lines. This is section 3-2 in your textbook. The essential question for this section is, what are some of the properties of parallel lines? In the previous section, we talked about lines, their transversals, and some of the properties of the various angles that are formed. We also, in the written exercises, conducted some experiments where the lines were parallel, cut by a transversal, and what the different properties were of the various angles. Well, in this section, we're going to formally define some of those properties. And the first is going to be in the form of a postulate. Postulate 10 states, if two parallel lines are cut by a transversal, then corresponding angles are congruent. Now remember, a postulate is something that we accept as true and we do not have to prove. So what this is saying is, if we've got parallel lines and they're cut by a transversal, all the corresponding angles are congruent. So let's look at a picture of this. Say I've got two lines that are parallel, cut by a transversal, creating angles 1 and 2. Angles 1 and 2 are obviously corresponding angles. So what this postulate is saying that if angles 1 and 2 are corresponding angles, which they are, then angle 1 is congruent to angle 2. Now the same would be true for all corresponding angles. There's obviously 1, 2, 3, 4 pairs of corresponding angles, and they would all be congruent. Now the next fact about parallel lines is given in the form of a theorem, specifically theorem 3-2. This theorem states, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So again, let's look at an example where we have two parallel lines cut by a transversal. Our alternate interior angles are angles 1 and 2, and I'm just arbitrarily going to pick angle 3, which is the corresponding angle to angle 2. Now, you can look at the proof in the book, but basically, they take the given information, then they say angles 1 and 3 are congruent because they are vertical angles. We know that vertical angles are congruent. So we know that 1 is congruent to 3. We also know from the previous postulate, postulate 10, that angle 2 is congruent to angle 3. Because angle 2 and angle 3 are corresponding angles. So if 1 is congruent to 3 and 2 is congruent to 3, then by the transitive property, I know that 1 must be congruent to 2. And that is exactly what we're trying to prove. Now the next fact about parallel lines is going to be addressed in theorem 3-3. This theorem states that if two parallel lines are cut by a transversal, then same side interior angles are supplementary, or in other words, add up to 180. So again, look at our pictorial example here. We've got two parallel lines cut by a transversal. Same side interior angles are angle 1 and angle 2. And what this theorem is stating is that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Again, you can look in the book for the proof, or you can work on it yourself. I believe it's going to be given as an exercise later on. Now the last of these facts about parallel lines is addressed in theorem 3-4. This theorem simply states, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other one also. So again, look at our example. We've got two parallel lines cut by a transversal which is perpendicular to one of the two parallel lines. Well, then it becomes somewhat obvious that measure of angle 1 must equal the measure of angle 2, or that they both are perpendicular to the original lines. Now I would like you to find the measure of each angle named in the figure below and post your answer in the drop box. All right, now I would like you to find the measure of each angle named in the figure below, namely the measure of angle 1, the measure of angle 2, the measure of angle 3, the measure of angle 4, 5, 6, and 7. Post your answers in the drop box.